Let us understand how do we solve this popular trigonometry question in different ways to get effective solutions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up a very interesting question which is based on sine law and cosine law. This question can also be solved without using sine law or cosine law for that matter. Let us see how do we solve this question in two different ways. It's a popular test problem regarding fire towers. Two fire towers A and B of the same height are located 10 km apart. Rangers at tower A spot a fire at 42 degrees and rangers at tower B spot the same fire at 64 degrees. How far from tower A is the fire? So in such a question, a couple of things which are important to understand is, first, when we say that spots fire at 42 degrees or at 64 degrees, which kind of angle are we looking at? The first statement was clear to us that two fire towers A and B, same height, are located 10 kilometers apart. So based on that, we can definitely make one particular diagram, and which is kind of like this. So we have two towers, let's say tower 1 and 2 could be right there. So they are the same height. Let's call these, they are already given as tower A and tower B. And we are also given that the distance between them is 10 kilometers. Now, rangers in tower A spot fire at 42 degrees and rangers at tower B spots the same fire at 64 degrees. Now, when we talk about this spotting of fire, then the angle is which angle? It is the angle of depression. Now, this is not explicitly given in the problem. However, that is what is to be understood. So, that's kind of tricky. Most of the time, we will indicate which angle you are looking at. Okay. Now, let's say the fire. So, from B, it is 64, from A, 42. So, it could be something like this, right? So what I'm trying to say here is that angle of depression is this angle, which is with the horizontal, and that angle is 42 from A and is 64 degrees from B. You get the idea. So that is how the situation is. And what you need to find is how far from tower A is the fire. So we need to figure out what is this distance x from tower A to, let's call this point as F, fire. Perfect. So I hope the situation is absolutely clear. Now to solve this question, we are going to use two approaches. One is using right triangles. Since many of my students who are still in grade 9 or 10, they have not done sine law, and so they cannot use sine law. And the other will use the approach for sine law. So with these two different approaches, we are going to solve this particular question. Okay. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. Some are there right at the top, getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Okay, so let's first solve this using right triangles. So once again, let me just sketch the diagram right here. We have two towers, A and B, which are 10 kilometers apart. Let's write 10 here. And fire is spotted somewhere so that it makes an angle of depression which is given to us of 42 degrees from A, right? And 64 degrees from B. Perfect. We need to find the distance x between the base of A and the base of fire. Let's call this as F. You get the idea. So that is the problem. Now, if you want to solve it using right triangles, we need to understand that these fire towers are right up, and so we have a right angle triangle. If we have 42 degrees as the angle of depression, in that case, what is the angle here? Well, that angle should be 42 degrees, right? Is equal to this same angle, correct? So this is also 42 degrees. Similarly, here we have angle of 64 degrees. You get the idea. Right? We are also not given the height of the towers. Two fire towers are given to us, but their height, h, is not given to us. Let us say height is h. Now, if height is h, and we know these angles are 42 and 64, then we can relate height with this distance, right? Using tan theta. So what is tan of 42 equals to? So tan of 42 degrees is equal to height over x. Since x is the distance which we need to find from A to the fireplace. Now FB will be how much? Well, F to B will be 10 minus x, correct? If this is x, correct? Because total is 10. Okay. So we have two different equations. One, tan 42 equals to h over x, and the other, tan of 64 is equal to h over the distance, which is 10 minus x, correct? So we're looking into the two triangles separately, right? If you want, you can label, let's say this is C and D, right? So here we are looking at the triangle ACF, right? And then we are looking at the triangle which is BDF, right? Now from here, you can write down what H is, right? And then equate to get the equation. So from the first equation, H is equals to x times tan 42 degrees. And from the second, H is equals to 10 minus x times tan 64, correct? Now both the values are indicating the same height. These heights are equal, right? So that really means I can equate equation 1 with equation 2. So I get a relation in terms of x. So we have x of tan 42 degrees is equals to the distance between them minus x of tan 64. You get the idea. So that gives us our main equation. Now this particular equation is only in one variable, x, and so you can easily calculate x from here. I am purposely not calculating the values of tan 42 and 64 since I am arriving at a general expression. Instead of 42 or 64, it could be any angle alpha or beta. So we'll get a general solution. You get the idea. So remember what equation we got. X tan 42 equals to, which is this angle, right? 10 minus x of 64 degrees, right? Let's move on to a new page. So we have x tan 42 degrees is equal to that distance 10 minus x times tan of the other angle, which is 64 degrees. Makes sense, right? Now to calculate, we'll just expand. So we get tan 42 with x and 10 times tan 64 degrees minus x times tan of 64 degrees, correct? Now bringing the terms together, we can write x times tan 42 degrees plus x times tan of 64 degrees is equal to 10 times, which is the distance between them, tan of 64 degrees, correct? So taking x common, we can write tan of 42 degrees plus tan of 64 degrees is equals to 10 times tan of 64 degrees, correct? So now from here, you can write what x is. 10 times tan 64 divided by the sum of these two, right? You get the idea. So let's rewrite our expression. And we say x is equals to 10 times tan of 64 degrees divided by tan 42 plus tan 64 degrees, right? Do you see that? We arrive at a general expression. At this stage, I'd like you to look into it more carefully, right? The whole process which we are doing here is a learning process. So if I generalize my statement, right, which is to say, if I have the case, which is kind of like this, that this angle from one place is alpha, the other angle is beta, right? And the distance is d. And we need to find the distance x. In that case, what is x? Well, we could write a general expression for this x, and this x is indeed equal to the distance d, right, which was 10 in previous case, and then tan of beta. We are finding the distance from A. Do you see that? So the angle of depression from B has been taken in the numerator, and the denominator is sum of tan alpha plus tan beta. Do you see? That really becomes a general expression which we can use to calculate and find solution of such problems. Do you see that? So we have actually derived a general expression. You can use calculator, evaluate this, correct? So I'll leave that for you. Or should we do it? Okay, let's do it. So we have 10 times tan of 64 degrees, which is equal to 20.50. And we are going to divide this by, within brackets, tan of 42 degrees plus tan of 64 degrees, right? Bracket close. And that gives you approximately 6.94. We need to, how far are the towers from the fire? So it is 6948, right? That is the answer. You can round to one decimal place, then it will be approximately equal to 6.9 meters. Is that clear to you? So that is the answer for the given question. I hope the steps are absolutely clear along with the general formula which we just derived, right? That's the beauty of this solution. Now, let us try to answer the same question using sine law, right? So once again, I'll just sketch the diagram here, correct? Two towers and something in between, which is fire in this case. Perfect. Both are at the same height, and the angles are given to us as 42 degrees and 64, right? This distance is 10 between the towers. Now, in this particular case, we need to find distance x, which is from tower A to the fire, right? So we labeled A here. This was fire and this is tower B. That is the distance which we need to figure out. So how can we do this? Well, if you see, we are given the two angles, we can find the third angle, right? So how much will this be at F? Let's label this as C and D. So angle CFD is how much? Well, angle CFD will be 180 degrees minus 42 plus 64. Let me write 42 plus 64. 42. Okay. So we can find the angle in between, right? So it becomes 180 minus the sum of 42 and 64. That gives us 74 degrees. So this angle here is 74 degrees. Now you can apply sine law. You see that? So 10 over sine of 74 should be equal to CF over sine of 64. You see that? The other angle, right? So with that, we get the value of CF, right? So CF is equal to 10 over sine 74 times sine 64. How much is that? So 10 times sine of 64 degrees, and then we are going to divide this by sine of 74 degrees, 9.35. So we get this side as 9.35. So actually this is the line of sight distance from top to the floor. Sometimes that is asked, right? Okay. Well, we need to find x, which is from A to F. Since we know that this angle is how much? 42 degrees, right? We know the hypotenuse and the angle, so adjacent side can be found using cosine law, right? Or cos theta, right? So we know that cos of 42 degrees is basically equal to AF over CF. So from here we can find AF as product of CF and cos of 42. Makes sense, right? Get the idea? CF is already known to us, 9.35, right? So let's calculate this. So in our diagram, which was, once again, I'm going to draw it. Okay. So we found that this side was 9.35. The angle here was 42. And the side which we are interested in finding is this x, correct? Right? That's the right angle triangle. And we say cos of 42 degrees is equal to x over 9.35, right? And therefore, x is equals to 9.35 times cos of 42 degrees. And that is equal to what? Let's calculate. 9.35 times cos of 42 degrees. That gives us 6.94. And again, we can round it to 6.9 if the answer is required in one decimal place. Since all the units are in kilometers, this distance will be in kilometers, right? So our answer here is fire is 6.9 kilometers from base of tower A Is that clear to you? So earlier also, we got the same when we used our approach of right triangle. And we also got the right angle triangle solution in a general form. Do you see that general form? So I'd like you to go through these two solutions and the approaches, and I hope they help you to understand the topic better. I hope with this, all your concepts are absolutely clear. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.